Hello, everybody. Um, Greetings. So we are going to start with term 3 work. Okay. So for term 3, I want to introduce 3 new concepts today. Okay, that we're going to do in term 3. It's what is mole, concentration, and empirical formula. Empirical formula. So what is so okay, let us use the following. So a mole, which is N. So N is calculated by, we say M over capital letter M. Or we can use, we can say N equals to V. If you have volume, you use this formula, V over Vm. And then you can also use, if you have a number of particles, okay? And then we use Na. Now, so, okay, what do these symbols mean? Okay, what do they mean? Okay, let me write it down here to show you what they mean. So the N, so we write down the meaning and so this is a number of moles. Okay, the N stands for the number of moles, and the unit is mole, F-M-M-O-L, and then the small letter M. There is the small letter M, and then there is the capital letter. So this is the mass, okay? And the mass is measured in grams. And then the big M is the molar mass. It's the molar mass, and the molar mass is measured in grams per mole. And then there is V, which is the volume, and the volume is measured in cubic decimeters, dm cubed, cubic decimeters. And then we have N, capital letter N, which is what? It is a number of particles, and then we have Vm. So the two The last two, they are constants, Vm and Na. Okay. So this is the molar gas volume as a constant. Okay. So the molar gas volume is a constant and it is measured. So it's just the number is 22.4. So this is the volume of 1 mole of gas at standard temperature and pressure. So, and then the last one is Avogadro's number. Okay, again, is also constant. So it's 6.02 multiplied by 10 and then exponent 23. Okay, so now what is, so this is a list of formula in terms of getting the number of moles. Okay, this is what we're going to be using. This is what we're going to be using. Okay. So we use, this is what it means, and those are the symbols that we're going to be using here. Okay. Now, for the definition, okay, the definition that we define a mole. Okay. Now, the definition is also important here. So, the definition, okay? What is a mole? So a mole is a, so we define it, we use carbon here. We use carbon 12 to define a mole. Okay, so we use the element carbon. Okay, so what is a mole? Is the number of particles of a substance. Okay, it is the number of particles, of a substance. The number of particles of a substance that is the same as there are atoms in 12 grams of carbon 12. So this is the definition of a mole. Okay. Now we use this definition. We make reference to carbon 12. Now, okay. Let us move to concentration. Okay. Now let us look at concentration. Concentration. So we can use, so C, okay? What is happening? Okay, I'm sorry about that. Let us erase. So C here will be equal to N divided by V. Or we can substitute the N, and then we have M divided by MV. Okay. So the new thing here on this formula is the C. The C, which is the concentration. This is the concentration, and the unit is mole per cubic decimeter. So all the other symbols, the N, the V, the M, the capital M, and the V, they are the same as described previously. Okay. So they are the same here. The N, the small letter, and the capital letter, and the V. So that's the volume, the molar mass, the mass, and the number of moles. Okay. So in this case, the new thing here is C, which stands for the concentration. Okay. So now the definition. Okay. What is the definition here? The definition, concentration. So what is concentration? So this is the amount of substance in mole per unit volume. So this is the amount. So this is what? The amount of substance in mole per unit volume. Okay. Or you can use any other suitable definition. It's not a problem. Okay. And then now, let us look at the empirical formula. Okay. Because now for the empirical formula we use, there's a table that we use. Okay. Empirical formula. The empirical formula. Okay, let me begin with the definition before I show you the table. Definition. Empirical formula is what? It is the simplest whole number ratio it is the simplest whole number ratio of atoms in a molecule. So this is the definition here. It's the simplest whole number ratio of atoms in a molecule. Okay. Now, okay, let us, sorry about that. There is, okay, let me do it here. Let me do it this side. So, table used. This is the table used for the empirical formula. For the empirical formula. So, okay, we have 4 columns here, okay? We have element. So in this column, that's where you write down your elements, okay? And then we have G over 100G. So this is going to be a percentage, okay? So all the percentages come in this column here, okay? And then the third column here is the number of moles, okay? We say M over M, capital letter. So the capital letter is obtained from the periodic table. And then the last column, this is where we have the simplest ratio. So the simplest ratio, because remember, the empirical formula by definition is the simplest whole number ratio. So the numbers are taken from here and we divide by the smallest number to get the simplest whole number ratio. And then the molar mass, the mass, I meant to say, is obtained from the percentage column here, G over 100G. Okay. And then the elements are written down here. Okay. I think you will see while we're doing examples. Okay. I will show you how we get the numbers. How we get the numbers from here to here to here. Okay. So if you don't understand, so don't worry at this point, isn't it? So what you should know is that there is a table, and the table has 4 columns. Okay, there's 4 columns that we use. Now let us begin with the moles. Okay, the mole here, the mole concept. Let's do an example together. Okay, let me go here. So let me use this as an example here so we can do this question together. This is from Northwest, November 2024. Okay, and it's from Northwest. So let's use question 8 here. Let's do question 8 together. 8.1. So they say define mole. Okay, so we must write down the definition for mole. 8.1. Okay. So what is this? This is the number of particles of a substance that is the same as there are atoms in 12 grams of carbon 12. Again, we make reference here to carbon 12 specifically. Okay, so this is the definition: the number of particles of a substance that is the same as there are atoms in 12 grams of carbon 12. Carbon 12, let's say. And then, so let us read the question together. It says what? There are several steps in the production of fertilizers. In the third step, nitrogen dioxide is absorbed by water to produce nitric acid. Nitric acid and ammonia can react together in an acid-base process to form the salt ammonium nitrate, which is soluble in water. Okay, so they gave us the 2 steps here. Give the scientific name of nitric acid. So nitric acid is this over here, HNO3. So nitric acid is written HNO3. So it has 2 parts. It has 2 parts here. There is H plus and then there is NO3 minus. So these are the 2 ions that make up nitric acid. Okay, so we're going to say this is a hydrogen ion, this is a nitrate ion. So meaning the scientific name here is going to be hydrogen nitrate. Hydrogen nitrate. hydrogen nitrate. And then we go to 8.3. 8.3, 8.3.1. Now, here we're given, say calculate molecular mass of ammonium nitrate. Okay, ammonium nitrate. Ammonium nitrate is here. Okay, so molar mass for what? Ammonium nitrate. So NH4 and then NO3. So it's gonna be, we add them together. So again, we go to the periodic table. Okay, let's see. We come to the periodic table here. Okay, so nitrogen is 14. There's 14 here. Then hydrogen is 1. Okay, oxygen is 16. So okay. So then we're going to have 14 plus, and there are 4 hydrogen atoms, so it's going to be 1 multiplied by 4, then plus 14, then plus 3 multiplied by 16. 3 multiplied by 16, and then it's going to be we add, so you use a calculator here. It's going to give you 80 grams more. Then 8.3.2. Now for 8.3.2, on the other hand, number of moles of ammonium nitrate if 15 grams of it was formed. Okay, so they say 15 grams. So we're going to say N equals to M, then divided by M. So the M is the 15, okay? And then the capital letter is the one that we found here. It's the one that we got from the periodic table. See it? So it's 15 over 80. Then you use your calculator, you get 0.19 mole. Eight point 3.3. The volume of 12 grams of nitrogen oxide. Okay, nitrogen oxide at standard temperature and pressure. Okay, so in order to get the volume, what must happen? We must have the number of moles first, isn't it? So we should get the number of moles first. Or, okay, or we can do it this way. Volume N here is going to be equal to volume divided by molar gas volume. And then we can substitute the N with M over M. So we can say mass divided by, then we divide it by the molar mass, and then equals to V over Vm. Okay. And then, so nitrogen 12 grams. They gave us 12 grams. Okay. Nitrogen oxide is nitrogen and oxygen. So the mass here is going to be 12. And then the M, okay. Sorry. They say nitrogen oxide. Okay. Nitrogen oxide is here. So it's NO. So it's 14 plus 16. Okay. So then we're going to have 14 plus 16 equals to V divided by the constant. This V is a constant, is 22.4. So then we're going to have V equals to 22.4 and then multiplied by 12 and then divided by 30, then equals to, so you use a calculator here, it gives me 8.96 cubic decimeters. The volume is dm cubed, cubic decimeters. Okay, so we had to see here, we had to see that we don't have the number of moles, but we have the mass. So we can replace N with M over M such that we can get the M, because such that we can substitute here. The capital letter is obtained from the periodic table and then the mass we were given. So then we can calculate here. Okay, we can cross multiply and calculate. So now let us go to 8.3.4. 8.3.4, what are they saying? Number of nitrogen atoms present in 2 moles of ammonium nitrate. So we can see that ammonium nitrate is NaS. Each molecule has 2 nitrogen atoms. Okay, so if they say 2 moles of ammonium nitrate, what do we do? We look at, because we're looking at the number of nitrogen atoms. Okay, but then for the nitrogen atoms, we have to see that there are 2 nitrogen atoms for 1 mole. Okay, so it means that for 2 moles, so okay, we have to find the number of moles of what? Of nitrogen atoms. So the number of moles for what? For nitrogen is going to be 2 multiplied by 2, which is going to be 4 moles. This is for nitrogen. Okay. And then we can say N equals to N over Na. Na is a constant. And then so we can change the subject here. We can change the subject, and then we have N equals to, the number of particles would be equal to N multiplied by Na, which then is going to be 4 multiplied by the constant for Avogadro is going to be 6.02 multiplied by 10, 23. And then so this place, then it's going to give us 2 point, okay, if you round to 2 decimal places here, okay, you round to 2 decimal places, it's going to be 2.41 multiplied by 10 to the power 24 nitrogen atoms. This is the number of particles. So we are talking about nitrogen atoms in this case. Okay, so the N here, what had to happen here is the N had to be multiplied because it had to be multiplied because for each ammonium nitrate, there are 2 atoms of nitrogen. So we multiply the number of moles by the number of atoms in each molecule. You see? So it gives us 4 moles. Okay. Okay, so yes, that was it for this question. Okay, let's leave it here for now, okay? Let's leave it here for now. We will continue next time. Okay? I hope that was helpful. And leave your questions in the comments. If there's anything you don't understand, leave your questions in the comments and I will attend to your questions. Okay? Take care. Bye-bye.